we're going to create a little spreadsheet that calculates how far an object, if it's dropped, how far it will fall in meters. Let's put a little title up here. We'll call it Object in Free Fall, and time in seconds, and distance in meters. Now we'll start off, we'll do at 1 second intervals here. And the equation that allows you to calculate how far a dropped object will fall in a time t is 1/2 gt squared, where g, at least on the Earth, is 9.8 meters per second squared. So we're going to put in a little formula here. And, we always start formulas with an equal sign. That means that it's going to calculate something as opposed to being just some letters or numbers that you enter as data into a cell. So 1/2 is 0.5 times, and on the Earth, g is 9.8 times t squared. Now what we're going to be doing is we're going to be calculating this for a series of different times. And here's the time in row 4 is 0 seconds. But I'm not going to put in 0 squared. I'm going to put in A4. A4 times A4. That's our squaring. You can also do A4 caret 2 for squaring, but I'm going to write it as A4 times A4. So, and no surprise, in 0 time, an object that is dropped will not fall at all because it hasn't had time to fall yet. But if I select that formula in cell B4 and look at that little black square in that corner, I'm going to grab that and I'm going to drop it down or drag it down, and notice that these numbers are not 0. In cell B5, it's taken A5 as the time, 1 second. In cell B6, it's taking A6 as the time, 2 seconds. And in cell B7, it's taking A7 as the time, which is 3 seconds. These are called relative references. The formula in cell B4 referring to A4 is saying take the time as the cell immediately to the left. So when you copy the formula down to the next row, it takes the time for that row as the cell immediately to the left. The cell immediately to the left. Relative references. Relative to this square, the time is the one square, or one cell to the left. Now, the problem with this is that we have put that 9.8 into the formula. If we wanted to calculate how far an object dropped on the moon, for instance, or Mars, or a different planet where little g is not 9.8 meters per second squared, then we'd have to change the 9.8 and recopy the formula throughout the entire table. A much better way to go would be to have another cell called little g that contains our value of little g, and we could change that one cell, and that would update the entire calculation in the entire spreadsheet. And we'll see how to do that in the next video.